Okay, so here we have a different devices are there. For example, hubs, switches, routers. Networking devices are there. Okay, for first hub. Why it is mute. Switches. Repeater, switch, router, wireless, point, okay, modem. Different type of modems are there, internal modem, external modems. So different type modem parts are there, of course. And CSU, BSU, DCE, DPE, firewalls, checkpoint devices are there, like a firewall, checkpoints. Yeah, so there is so many networking devices, CSC, DSU, firewalls, checkpoints. Yeah. Different set of cable connectivities also there, so we don't go to that much. Okay, guys. So these are the so many devices are there, but out of that one, we are going to discuss about hub, a repeater, switch, router, and modem. These are our main discussion points. So just to note that we are using this kind of stuff, and how we connect also again, once again we will see, because already I told SOHO, but again I will try to show you that one. Simply to tell what are the basic networking devices and with a simple description. With a simple description means you don't have a time. So what is what? Also we can give in a single line. Also we can give for a simple explanation. Guys, hub is a layer 1 device. We use hub in a LAN communication and small networks. It is a non-intelligent device. It is a non-intelligent device, layer 1 device. Is a L1 device. As per OSA layer, it is a layer 1 physical layer. Okay, I don't write everything. So it is used for LAN communication, small networks. Repeaters are to repeat the signal. Okay, to repeat the signal means normally our UTP STP cables support up to 100 meters. Now I want to
Sir,
communicate more than, yeah, tell me.
sir, hub is also broadcast the messages, no, sir?
What it
It is also
is?
used for broadcasting the messages to each and every device connected on the
Yeah,
network.
that is we will
Hub.
discuss. Good. That is we will discuss. Okay.
Okay, sir. Okay.
I'm telling very basic level.
Okay.
Very basic level. Okay. So small points are there. We should add it. So just basic. Repeater
Okay.
is a device used to repeat the signal. Means I want to communicate long distance. Means UTP STP cable support 100 meters. I want to communicate my next device is in a 150 meters. What I will use, I will put a one repeater there, just like a Wi-Fi extender. Okay. Next one is switch. Switch is also used for LAN. Hub and switches both are LAN communication. Switch is layer 2. Switch understand MAC address. Switch use for both small and large networks. Hub is small networks only. Only 4 or 5 devices we can connect. We cannot connect a 20, 30 devices in the hub. In a hub network, it should not connect 20-30 devices. In switch, we can connect. So 30, 40 or 60 devices. Like that, we can connect a very large number of devices we can connect. Okay. Both are for LAN communication only. Next one is router. Router is used for both LAN and WAN connectivity. Means you have a network. There is a network. It is a LAN network. And there is another network that is in different LAN network. We can connect these two networks through router using LAN or WAN protocols. We can able to connect it, right? So LAN connectivity is there, WAN connectivity, both are there for router. Router is a internetworking device, means which make a communication between two or more different networks. Communication between two or more different network is internetworking. So router is an internetworking device. Router shows best path to reach the destination. I want to access google.com. Google.com is not in my LAN network, right? Somewhere it is located, some different geographical location Google server is there. How can I reach? With the help of routers only. Router shows how to reach the destination. Next important device is modem. Modulator and demodulator. The modem is used to connect internet. Means you are connecting, your network is connected to ISP. ISP allow you to connect internet. You are connecting from your local LAN network to ISP using modem. So once you are connected, once you are established the connectivity to ISP, the ISP allow you to access internet, public network. So we can connect either using a telephone cables or a fiber optical cables. So different way of connectivity is there. PPPoE type of connectivity or Ethernet type of connectivity is there. So this is the basic points. So these are the main devices: hub, switch, router, and modem. These four devices are important. So hub is for small network. Hub and switches for both LAN communication, router is for LAN and WAN, and router is internetworking device. It shows best path to reach the destination. Modem used to connect to the internet via ISP. So you are connected to ISP using modem via using telephone cable or optical fiber cables. So ISP allow you to connect internet. So now we'll go to one by one, guys. Hub, switches, routers, kind of stuff. Whatever the matter it is, I'm going to remove some matter. I will going to add some matter here. So that's why notes as well as the PPTs, both are important. Same links only. I'm not changing any links here. Basic circuit board. Hub is directly a hardware kind of stuff. Hardwire, wire, not hardware, hardwire kind of stuff. Means each port is connected to other ports. It is not having any intelligence, means no specific circuit for understanding packet or any part of packet. You don't understand. It will receive and forward kind of stuff. It is not a intelligent device. Why? Because of it does not understand MAC address or a IP address. It does not understand MAC address or a IP address. What switch will do? Switch broadcast the packets to every device in the network. Switch broadcast the packets to every device in the network. What is that meaning? Meaning is to draw picture. Okay, this is a hub device. Hub. This one. I'll write here. This is the devices hub. And now this is PCA. Okay, PCB, PCC, PCD. Now, so here I'm telling send packet PCA to PCB. This is a PCA to PCB communication. Otherwise, more this one, so put like this. This is hub. I'll take another one. PCA to PCB communication. Now you know what happened. Sorry. The packet will send PCA to the hub, this particular port. Okay, and this hub will forward this packet. Hub will send a packet to, this is PCB and PCC, PCC and PCD also. Okay, packet is sent to every device. Packet is sent to every device. In the network. Okay, packet sent to every device in the network. This is called a broadcasting. This is called a broadcasting. What switch is hub is doing? It broadcasts the message to every device in the network. Shared bandwidth, all are nonsense. Okay, it broadcasts the packet to everyone in the network. Everyone in the network. Okay. It is suitable for a small networks. We use for LAN communication. Suitable for a small networks. Why small networks? Because hubs are generally the less ports. The number of ports for a hub is also less. Why less? Again, so because of this broadcasting, think like this. A packet is traveling through same way, means okay, A, B, C, D, like that. More devices. Think like this, more devices connected through hub. Okay. So what happened? The packets are forward to everyone. Packet is sent to everyone. And same way, so B2C communication. Again, packets are sent to everyone. So what happened? The same path is collide with the different packets. Okay, so the collision will occur here. The collision will occur here. Broadcast is occurring from here and collision is also occurring here. Okay, so then the collision means packet is traveling, another packet is traveling in same way, and some other packet is traveling in other same way, means opposite way in this particular hub, because no separate paths are there. So obviously the collision will occur. Because of this collision, packet data loss. Okay, so hub we call it as a single broadcast domain. And a single collision okay. So because of this number of collisions occurs, the packet data loss is there. Okay. So again, I'm telling point, guys. Hub is not a intelligent device. It does not understand MAC address or IP address. It is a layer 1 device. It is a layer 1 device. OS a layer 1 device means it is a physical layer device. It is suitable for small networks used for LAN communication. Okay. It broadcasts the packets to every device in the network. Those devices are connected to the hub. So directly it will broadcast the packets. That's it is called a single broadcast and single collision domain. Okay. Because of these collisions, because of number of collisions are high, the packet data loss is also there. This is about, guys, underline points important. That's why I didn't underline all these things, because if you cannot remember, then it is like again it is confusing. Okay, that's why compulsory remember few points, that to underline points. It does not mean it is not important. Okay, right. So important one is, as you guys said, like that is a good one. But it is broadcasting. Broadcast packets to every device. Like A send a packet to B, A send a packet, but the packet is reached to B, C, and D. Okay. Of course, B accept the packet, C and D discard the packet. But unnecessary data is transmitting. That is the hub. Repeat the signal again, so then you can send a packet to the longer distances. Repeat the signal, so then you can able to send packet to this. So you can use hub as a repeater. Another example for repeater is Wi-Fi extender, but I want to show you how repeaters look like. This is hub and a repeater. About active and passive hub, that much I don't know. Okay. This is how hub and this is repeater is there. And I want to show you the Wi-Fi extender. What is this Wi-Fi extender? So you have a Wi-Fi router is there in your home. You have a Wi-Fi router is there. So and you are sitting in a longer distance. You sat in a very long distance. Now what happened? You're unable to receive complete signal, only 1 point signal or no point signal, because your hall is very big or a room is in different place. Okay, so at the long distance or maybe some mostly objections are there. For example, I currently in office, I sat in one room. It contains a glass door, the glass type. Okay, so I can't able to receive complete signal. Okay, last Friday I sat in another room, so a different room, but there I am getting good signal, but here in the same big hall I'm not getting full signal. Okay, of course that's why I'm using cable for getting internet directly, good with 100 Mbps directly I'm getting. 90 Mbps, 93, 92 Mbps I'm getting. Okay. But what is this user Wi-Fi extender? Wi-Fi extender receive a signal from your Wi-Fi router. Okay. This Wi-Fi extender, what it will do? You have a Wi-Fi router and somewhere you are sitting here. Okay. This Wi-Fi router generate a signal, but you cannot able to receive for you. So what it will do? It receives the signal. Okay. It captures the signal. Okay. It takes the signal. Okay. And it repeats the signal, same signal strength. So originally you are communicating through this main router only, but this will help you to get the proper signal. That's it. It don't boost the signal. Repeater don't boost. Repeaters do not boost the signal. Okay. It is not a signal booster. It is not a signal booster. Some people think it is a repeater or any word we use. It is immediately it is a booster signal. No, no. Example is Wi-Fi repeater. This is also a good example. This is wired repeaters. Hub, repeater, and Wi-Fi extension. Okay, guys, do you understand what is hub and repeater?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Yes, sir. Yes,
So
sir.
next one is switch. Next one is switch. Switch is an intelligent device. It understands MAC address. It is a layer 2 device. Okay. Switch understand MAC address. Okay. Switch understand address MAC address. It maintain a MAC address table. There is what's in a unicast method, floating methods are there. That is a different points. I will tell unicast part. And in a switches also we have a cut through switches, store and forwards type of switches also there. And basically the switch functions are MAC learning and forwarding is mainly two major functions are there.
The unicasting means one-to-one communication, no?
Unicast means one to
One-to-one
one
communication.
one
Yes,
to
sir.
one. Okay, there is a few points. This is I want this point. I want to add here. Again, hub and switches both are for a LAN communication. Hub both are for LAN communication. Okay, and switch is a layer 2 device. Use it for a small and large networks. Switch understand MAC address. Switch understands MAC address. Okay, we can connect large number of devices. Number of collisions are less, so packet loss is less. no underscore here. Switch is a things here because of switch initially broadcast packets to the devices in network like hub. Later unicast packets to devices using MAC address table. Using MAC address table. What is MAC address? You know already. What is MAC address table? Okay. Then MAC address from packets map MAC address to port. Okay. Maps MAC address to device MAC address to where that device connected is called MAC address table. Okay, so these are the mainly two lines, guys. So it is somewhat important. So try to understand this kind of stuff. This last part I will explain, but switch how switches look like this. We don't have a space here. Switch is an intelligent device. Switch understand MAC addresses. Switch is used for small and large networks. Switch is for LAN communication. It is a layer to device data link layer. Switch initially broadcasts the packets to devices in the network like a hub. Later it is unicast the packets to devices using MAC address table. What is a MAC address table? How MAC address table created? Switch learn the MAC addresses from the packets and maps device MAC address to the switch port number where the device is connected, called a MAC address table. Okay, so how it is connected also I will put it here again. So this is the place where I put a diagram. So slowly look at this. This is a big picture, guys. Okay, this is one PC. 1, 2, 3, 4, 5. I'm taking very less devices, like a hub only. I've taken it. So normally, if I'm using a paintbrush, I will use more more devices. So this is the switch. Every switch or a hub having their port numbers are there. Okay. For example, here 1, 2, 3, 4, 5, 6, 7, 8. Think like it is a 8-port switch. Think like it is a 8-port switch is there. This is a PCA, PCB, PCC, and this is PCB. These are the devices. This is the switch. Okay. Now what I am trying to do is I am going to connect this thing like a PCA is connected to port number 1. That is the problem. Okay. And PCC is connected to port number 3. PCB is connected to port number 4. PCD is connected to port number 6. Okay. Because this connectivity, okay, like this it is connected. Now what happened? Communication, A to B communication only. PCA to PCB. Okay. So guys, not a drawing, understand what I am trying to say. Okay. So PCA to PCB. As I said, initially it is broadcast, right? So PCA send a packet to our switch. Switch send a packet to B and C and D also. Okay, but CPC accept the packet. Accept the packet. BPC accept the packet. CPC don't accept the packet. It drop the packet. But there is a MAC address table. So we have to construct this MAC address table. This is called a MAC table or a MAC address table. Short form is MAT. Already said it maps the things like it understand PCA MAC address. This is the MAC address. This is port number, switch port number. That's not required. Okay, so here look at here. So A1 is a MAC address. Here for this PC, think like B1 is a MAC address. Just for example, here C1 is a MAC address. Here D1 is a MAC address. While I'm sending a packet, my packet contains MAC address, right? So my MAC address, PCA MAC address is A1. It is connected to port number 1. Okay. Same goes like a next communication. For example, next communication PCB to PCC. Now PCB to PCC communication. So same thing again. PCB send a packet, and where is the C? We don't know. So then we'll send a packet to everyone, and remaining will be drop the packet. PCC received a packet, but our MAC address table, what it will do? You take the B1's MAC address and check which port number it is. B1 is connected to 4 port number. Like devices are communicating each other, devices while communicating each other, it creates the MAC address table. B1 is connected to 6.
This MAC address is already defined in the switch.
No.
It
Every
defines
PC
device.
has a MAC address, right? Every NIC has a MAC address. Every PC's NIC having a MAC address.
Okay, sir.
Right? So I'll make it more easy for you. So this is my device. This is the switch. This
Hello,
is another
sir?
device. Yeah.
Hello, sir.
Yeah, tell me.
Sir, can you demonstrate the practical on Cisco packet tracer?
It will take time.
Okay, sir.
Actually, I
So
want
it is
to
easy. It is easy to understand now, sir.
for some people.
So what is Cisco packet tracer? We are hearing first time.
Funny first question.
Yeah.
Don't worry about it, guys. Look at here. First, understand each switch having some switch ports. Okay, switch port. This is APC. This is an NIC. This is a BPC's NIC. Each NIC having a MAC address. Right up to here. Each NIC having a MAC address. While you are communicating A to B, so what you will do, you send a packet to the switch. Okay, through port number 1, you are sending a packet. So the packet contains source MAC address, destination MAC address, source IP address, destination IP address. This is the addressing part of your packet. So what switch can understand? Switch can understand MAC address part. Switch can understand MAC address part. What is the source MAC address? A's MAC address. A's MAC address. Okay. So what switch will do? The switch A's MAC address means APC is connected to 1. So what is the A's MAC address? And port number 1. Okay. It maps like that. Now, for example, B is communicating to A, or maybe B is communicating to C, or B is communicating to D, or C is communicating to D. Anything. CPC is there. CPC is connected here. For example, it is a port number 3, and this is a DPC connected to port number 4. Okay. So port number 3. C to A communication, for example. Oh, sorry. I will come back to A. C to D communication. So CPC also having NIC. NIC is there means contains a MAC address. And DPC also having NIC. Is also having MAC address. Same way, source address, destination, source IP, destination IP. Packet travel through this port. Switch understand which port it is. Port number 3. What is C's MAC address? Map like this. Okay. So while devices are communicating each other, it maps each and every port number like this. B's MAC address. While B is send a packet to anyone, so B's MAC address and port number 2. D's MAC address port number 4. Can you see? All port numbers and what devices are connected to this particular port number. We got it. One second. Okay. Now think like this, guys. Think like this. MAC address table is created. MAC address table is created. Now I want to communicate D to A. Which one? D to A communication. DPC send a packet to 4, port number 4 to switch. And what is the destination? A. What is A's MAC address? Where is A's MAC address is connected? 1. So it will forward packet to the port number 1 and A will receive. So this is unicast. Initially broadcast. Initially it do broadcast because we don't know the destination, where is the destination, which port it is connected, my destination, we don't know. So what we will do it, we'll do broadcast initially, like A to B. A send a packet to switch, switch send a packet to B and C and D initially. But it create a MAC address table while it is going on. While this broadcast is going on, it create a MAC address table. Once MAC address table is created, means if the data entry based on the MAC address data entry is there, okay, so it will start doing a unicast. Here I give an example, that is D to A. What is D to A? D send a packet to A. So A's MAC address, destination MAC address is A's MAC address. Where is A's MAC address? Here it is connected to port number 1. So it will directly forward packet to port number 1. So this is how switch works. Okay, so that is the point I am trying to say. For example, here
Sir, I
it
have a
is.
question.
Yeah, tell me.
Sir, if the D is sending suppose packet to a port 4 and that port 4 is connected to 1 and sending and to the destination, that is a PCA. So the MAC address of A and PCD is same.
No.
Okay. It is just sending a packet to the destination from these ports, which is available in the switch. Or it develops a kind of MAT table. Then after sending this packet.
First of all, guys, yesterday lesson you may forget, understand each and every PC, including my PC. Okay, including my PC, mcpa.cpl, my laptop. Okay, having a NIC. What is the use of NIC? To connect network, to connect any switch or a router. Okay, so we use NIC. So this is my NIC, Wi-Fi adapter NIC. Every NIC having their own MAC address. Okay. What is physical address? MAC address. Okay. So every NIC having their MAC address. When I'm communicating from one device to another device, that will get clarified in OSL layer in generally. Okay. So when I'm communicating from one device to another device, while I'm sending a packet, okay, the packet means it is a information, there is a data in the packet, right? But you have to address, right? You have to write to address, from address, right? From A to B. DHCP resolves MAC Okay, a MAC address table for MAC addresses using switch managers to send data packets to destination. Don't get mix up one to another one. Okay, you are sending a packet from A to B, means to address is B, from address is A. So that is a source. This is destination. Okay, so from address. A PC having an IP address, right? So all communications by IP address first of all. A PC having an IP address, B PC having an IP address. With IP address, you are sending packet. But along with the packet, also it is attached a MAC address. A PC having the NIC, what NIC, through NIC, which NIC you are sending, that NIC's MAC address, that NIC's configured IP address. So this is the as a from address, from PC MAC address, from PC IP address. This is destination. We have sent a packet. This is two address, BPC IP address and BPC's MAC address, destination address. Okay. Sometimes you don't know the BPC's MAC address. In that time, you use a broadcast address, like 12 Fs are there. Nine Fs only, okay, 12 Fs. This is the broadcast address. Sometimes if you don't know the destination MAC address, but you must know destination IP address. If you don't know the destination MAC address, then we have to use MAC broadcast address. This is the addressing part. Okay, understand up to here, guys. There is a PC, there is a NIC, there is a connectivity. Each NIC having their own MAC address and IP address. Of course, MAC address is permanent address for NIC. IP address depends upon the network.
Yes, sir.
Okay. In case you are connected to hub, no, hub don't understand your PC MAC address or your PC IP address. You don't understand anything. When you connected the switch, so each switch having a, even hub or a switch having ports are there. Okay, port number 1, port number 2, port number 3. So I will show you this switch. Yeah, this is the correct switch. This is a TP link switch. See, can you see 1, 2, 3, 4, 5, 6 like that? So 24 port switch. These are the LEDs, indicates the connectivity. Link LED, activity LED. Okay, it is a 1 Gbps links are there, gigabyte switch it is. 9,000 rupees cost. Gigabit Ethernet. Okay, so this is the physical switch. This is, for example, port number 2. I am sending a packet. I take a blue color. I am sending a packet from A to B. Packet sent through this port to switch. Switch want to check where is the destination. Destination is B only. If two PCs are there, of course it is broadcast to B directly. If I have a multiple PCs, then to whom it has to send? Where is the destination? Where is the destination? This is port number 3, for example, port number 4. This is CPC, this is DPC. This is an NIC, it is also having MAC address. Okay, so what our switches do? Switch don't know where is the BPC based on the MAC address. What it will do? It broadcasts the packet to B, it send a packet to C, it send a packet to D, like this. This is called a broadcast. Okay, this is first point. Now, switch can understand MAC address part. Okay, switch can understand MAC address part. So what it will do? It create a MAC address table like a when it is receive a packet, A's MAC address is confirmed, right? So APC's MAC address, it collect APC MAC address and create where it is connected. APC is connected to port number 1, APC MAC address and port number 1. So device, it is identify the device with the MAC addresses only, because switch don't understand IP address, it understand MAC address. Okay, like this. So it is a MAC address table. Same way, for example, CPC is try to communicate it to DPC, C to D. Send a packet, support number 3, switch, distribute the packet, means send same packet to others. D is a main recipient, so D accept the packet, remaining drop the packet. Now switch received a packet from C, right? Received a packet from C and C's MAC address. So it understand C's MAC address because the packet contains source and destination MAC address. It understand C's MAC address and the port is connected through 3. Like that, it will create a MAC address table. It will create a MAC address table. Guys, understand up to here?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now what happened? If D want to send a packet to A, for example, MAC address table is there. So what it will do? D send a packet to switch. D send a packet to switch. And packet to switch. Check destination MAC address destination MAC address. Switch check the destination MAC address which is belongs to PC A1. Why A1 B1 guys? Because I cannot write a 12 hexadecimal number for each and every PC. I given example A1 B1 C1. Those are all example MAC addresses just for our understanding only. Original MAC address is not like 1 or 2 digits, right? It will be there with the 12 hexadecimal numbers are there. So what is my destination MAC address? A1, for example, PC1, that is A1. Okay. So check the destination MAC address, that is A1. Verify MAC address table. Verifies MAC address. So check MAC address table for where A1 is connected port. So what it is? It is port number 1, right? Port number 1. So switch send packet to port number 1 only. So this is the point. No, MAC address table, ARP table are different. Okay, so PCs are initially broadcast. It will create a MAC address table. Using MAC address table to unicast. Now see PCD to PCA, we are not doing any broadcast. We are sending packet directly to PCA. That's what I am trying to tell. These are all gone for the next part. Okay, now Palan. Okay, guys, that is the point about your MAC address. So switch also do MAC address learning forwarding. Already I told switch is a layer 2 device, but there is a L3 switches are there. So do not confuse when anyone told you that is what is the L3 switch. Don't confuse, guys. Switch is L2 device only. L3 switches are function like a switch as well as a router, because a router is a L3 device. L3 means it is OSL layer, layer 3, it is a network layer. It contains both IP addressing and routing protocols, means router. L3 switches act like a switch component is there, switch connectivity as well as a routing connectivity is also there, routing part is also there. Okay, mainly we are using these L3 switches in inter-VLAN routing. Inter-VLAN routing or VTP kind of communication we are using. Okay. So that is our L3 switches. Okay. So again, switch, guys. Switch is an intelligent device. Switch can understand MAC address. Switch can understand MAC address. Switch used for LAN communication, and both small and large networks we can use it. Switch is a layer 2 device, data link layer. Data link layer. Okay. So switch initially broadcast the packets to devices like a hub, later it unicast the packets to devices using MAC address table. It learns the MAC addresses from packets. It maps the device MAC address to switch port number where the device is connected. So based on their connectivity, it will create this MAC address table. Okay. So there is two more points are there. Switch is a single broadcast domain. Okay. Entire switch is a one single broadcast domain, and multi collision. Okay, it is not single collision domain. Hub is a single collision domain. This is multi collision domain. The collisions will occur at port number. Okay, because this is a, for example, a port. A device is connected to the port. Okay, there is incoming packets from different sources are there at port. The collisions will occur at this ports only, not to entire switch, not entire switch. That's it is a single broadcast domain and multi collision domain. Large number of devices can connect. Okay, number of collisions are less, so less packet data loss. Yeah, that is the point. Yeah. So everything fit here. Okay, so we didn't done much faster because we spend a lot of time on such. No problem. Guys, understanding is very important. So understand, I think so, some points at least. How VPN
Yes,
take
sir.
role in an address. No, I don't go to VPN. Someone asked me, so show me in a packet tracer, and another one is asking me, what is packet tracer? Okay, the packet tracer is a Cisco uh, organization related a simulator software. It is a simple software, so where we can able to learn, also we can able to create the network. Means I want to implement a network for an organization. So I need a simulator, right? Like a mechanical guy is having a AutoCAD. There are so many other softwares to for a designing and as well as a simulating purpose, right? So networking, there is a multiple type of designing and simulation is there. Cisco Packet Tracer is a one of them. Like a Boson is a one of the network designing and simulation software. GNS3 is there, network analyzer, like so many simulators are there, virtual environment things are there. Okay, so one of the software is Cisco Packet Tracer, use it to design and learning purpose. Okay, simulating, not only just a drawing, also simulating. For example, this is a switch number is 2960. This is a simple switch. Okay, I want to create a small network. Actually, for your batch, I want to show from here, but I don't know how many people can really understand. That's why I didn't do it. So this is 4 PCs are there, and I'm going to connect all these devices through straight through cable only. So how to connect? So for Ethernet, right? This is Ethernet. This is Ethernet. Like that, we have to connect. Yeah, good one. Okay. So guys, this is the switch. This is how Cisco switches look like. Zoom in. Still, okay, one single zoom in only. These are the switch ports. Okay, like this. This is for a configuration, how it is there, how to connect, kind of stuff. This is the uh, software. Means it is a it is not non-manageable. It is a manageable switches, so we can configure it, and also we can see a few kind of stuff. Okay. So MAC address. Can you see the MAC address table showing nothing? So it is MAC address of a devices and where it is connected. So where it is connected to the links, you can see this is a PC0 is connected to 1, okay, and this is connected to 2, this is connected to 3, this is connected to 4. Okay, so this is the my PC, and I should configure IP address first. I'm configuring simple IP address. First PC is a .11, and of course I will show you the IP address. sorry. Second is 12. This one is, will go to 13. Okay. Guys, look at this is having its own MAC address. Currently it is not showing. So this is the MAC address of first PC. This is the MAC address of first PC. There is a note point is also there. Place a note. Okay. This PC MAC address. Second PC MAC address. I said notice this PC. I think 3 PCs are enough. Fourth PC MAC address. Okay, each and every PC MAC address, I hope you remember. Okay, now I'm communicating from one PC to another one. So first one to last one. Okay, so last one IP address is, what is last one IP address? 10.0.0.11. This is first PC. Desktop. Terminal, no, not terminal, command prompt. Just I'm sending a ping command 10.0.0.14. That is the last PC, right? I'm pinging, so I'm getting some reply. Okay, means both the way communication is happening. Means first PC to last PC to first PC, communication is happening. Remember, A to B, B to A, both are communicating each other. Now see the MAC address table. And meanwhile, other devices also communicated. See, this is the port numbers, and this is the device MAC addresses. Check it. First port number connected device MAC address. Is it the same? 13A 11C2 10010. Second device, second port number. So there is a MAC address 00605C 6842C4. Okay. Third device connected to third port number. Okay. It is also same. So yeah. 006070A 9BE6. Fourth device is the last device connected. Can you see? C94C1A0. So this is MAC address learning. Okay, it learned the MAC address and map to port number from the devices connected. Of course, by one communication itself, it is already learned where the devices are connected. So next time onwards, it is don't do broadcasting, it will do unicasting. That is simulation I didn't show you, just I showed only the switch and fork computer as I explained like this, only I showed. There is a simulation is also there. If you want, I can able to show you that one. It. Okay. I don't need a switch, I need a hub. This is hub. Okay. Now I'm connecting all these devices. All are configured with IP address. Okay, this is hub. These are connected configuration attributes. Nothing to do it. It is a already pre-configured one. Okay, so no routing table kind of stuff. So when you are communicating, this is 11. I want to communicate it to 14 again. I am able to communicate. Communication is there. Okay, successfully you are communicating, but we don't learn any MAC address here. The point is simulation. Okay. The simulation, we have to start simulation by sending packet. Where the packet? Yeah, this is the packet. This is from address. This is to address. Means from PC0 to PC2, I'm sending packet, guys. Please check it. So this is my packet. You can see the packet. This is the IP address, source IP, destination IP address. Okay, ICMP means it is ping protocol. This is how packet is look like inside. Source IP, destination IP, what protocol, what flags, and all kind of stuff. So I'm forwarding one step. Packet sent to hub. Okay. Now hub is sent to everyone. That is a broadcasting. And these two packets are dropped here because it is not a originally not receiving type. It's not for them. Their destination address is different. They drop the packet. This is accept the packet. This is accept the packet. Now it will start from here. It means PC2 is going to reply to PC1, PC0. From here to here, it will go for reply. So it is send a packet. Again, it will broadcast. Again, it will broadcast. So it is always broadcast. Do you understand the hub, guys?
Yes, sir.
Yes, sir.
So, very good. Now I will show you the switch part. You can feel the difference now. I'm connecting to the switches. Simulator manner. Okay. I connected 4 devices to the switch. Now I'm going to the simulator. Now packets, remove this packet. I didn't given any destination. Same destination only. So remove the packet. How to remove this packet? Source. Simulator. It's a new software now, so that is a confusion here. Reset simulation. There is a result page will be there earlier. Event list. Show all none. Yeah, this packet things should be removed. To remove this packet. Edit filters. Here actually success failure part is there. New cluster it is. Logical, physical. We are in logical. Reset simulation, constant filters. I want something. This toolbars, all toolbars are wrong. Show viewpoint, simulation mode, real time, logical view. So we'll go to real time or simulation. Okay, I will try to show you. So packet is sending to the destination. The original packet is connected to port number 0. The packet is going to the destination now. So it is directly sending to the destination. That is STP broadcast. It is, while it is doing, it created a MAC address table. But I need a resetting this simulation part is required. And this packet also should be deleted. I think so. We are already wasting our time. This is the thing. We got it now. You got it, guys. Don't worry. So this is the source. This is the destination. Okay, PC0 to PC3. This is the destination. So packet is this one. So what is the layer 3 protocol is? Source is 11, destination is 14. Source MAC address, destination MAC address already learned. Packet is sent. Okay. So packet is sent. So this is the destination. Already know where to go. So it is directly sending like a unicast. Like a unicast. Now MAC address table is clear. Again, I am trying to show you the simulation. So this is source packet, and this is the destination packet. This is source. This is destination IP address. So next one is packet sent to the switch. Switch don't have any MAC address table. What it will do? It broadcast. So switch initially broadcast the packet. Now these two are drop the packet, and destination is finally received a packet. And it is a ICMP ping type protocol, means it is giving reply. Okay, and wait. So I'm going to switch again. Show MAC address table. It will learn the first one. Okay, so PC0's MAC address it is. See, already learned MAC address of this PC0. Now it is replying. While it is replying, it learned this PC3 MAC address also. So PC3 is sending a packet to PC0. Okay, send a packet to PC0 through this switch. Again, It is 4. This is the MAC address of this PC. Okay, it learned the MAC address of this PC. Next. Finally, packet is received. Okay. So I'm deleting this table. Next, I am communicating from here to here. So packet send. So as per MAC address table, again we have to check the MAC address table. As per MAC address table, only 2 ports are there. First one and last one, not this one. Again, what it will do? It broadcast. In MAC address table, the MAC address of destination is not there. What it will do? It broadcast. And it will unicast to the A. Why? Because of that MAC address table is there. Last one, from here to here. From here to here. PC3. So 0, 2, 3. All these 3 having details in the MAC address. From here to here, is it going to unicast or broadcast? From 2 to 3. Packet sent to the switch. Switch check the destination MAC address, that is PC3 MAC address, where PC3 is connected. It will forward to that port. Now, why it is broadcasting? It is already there. It's actually the packet pollen. That is a packet pollen. We'll try second time, because initially that is a correct output only. So it is unicast. Okay. So what is, I said, a packet column? I will try to explain. PC2 to PC1. Okay, this is the packet I'm trying to send. So this is the source. PC is 13, destination is 12. Layer 2 protocol information is not yet added. Simulation. Packet sent to the switch. I will show you the switch packet. Can you see F's here? F's. What is the meaning of F? Broadcast. This particular PC don't know who is the MAC address of this PC. This PC2 don't know MAC address of this particular PC. That's why it is using broadcast. MAC broadcast. So obviously it has to broadcast to everyone. But now it is LAN, it is unicast. I think that is enough for you. Guys, understand difference between switch and MAC, switch and hub, MAC address, broadcasting kind of stuff.
Yes, sir.
Yes, sir. Sir, we have to learn this tool, Cisco Packet Tracer, completely.
Right. But if you want, you can learn. Learning is always best, guys.
Yes, sir. Yes, sir.
But not forcible. Okay. You want to learn, already I think so are given. If I'm not given, please check this website. It is a skills for all. Go to catalog in skills for all. Go to catalog. There you can learn networking basics, networking essentials, packet tracer basics also. Networking device initial configuration. This also covers packet tracer. Okay, separate packet tracer course is also there. Okay. So networking essentials, you can learn maximum things from networking essentials. Cisco packet tracer course is also there. 8 hours means maximum 2 to 3 days you will complete this course. If you know the packet tracer, so you can learn a lot of things like a CCNA, MCS, CCNA, CCNP kind of stuff also you can learn. One more site is there, that is called NetAcademy. Both are Cisco related. what you do. You know my already where I'm sharing things. This is mine, right? Go to playlist. There you can find free courses. Go to free courses. I told a lot of free courses available through online. You can access freely. Both how to log in and also I told in skills for all and NetAcad also. Okay, you can go through that one. A lot of free courses stuff is available. Okay, so now it is 1:30 guys. Actually, we can easily complete routers, modems, and topologies very easily, but we didn't complete this today. That's a sad thing. Yeah, people. Okay, that's it for today, guys. Actually, we have a lot of